Hello everyone, this is Sanya. I'm a data analyst. Today we'll be covering a new topic, central limit theorem. It is very important in statistics. Before jumping to this topic, there are some prerequisites that you should know. First is normal distribution, second is skewness, and third is standard deviation. So I will be mostly referring to these words. It's better you should know what are these and details about it. You can watch my previous video to learn about it. So let's start about central limit theorem. So now let's see what does this theorem means. It is a statistical theory that if you have a population with mean mu and standard deviation sigma and take sufficiently large random samples from the population, then the distribution of sample mean will be approximately normally distributed. Big words, let's cut it down and see what does it mean. Now for example, I want to take a population, say men living in Mumbai, and I want average height of men living in Mumbai. There will be approximate 10 million or 15 million men living in Mumbai. I cannot take data of all the population, so we need to take sample data. And first condition is sufficiently large random samples. So my work won't get completed if I take just 100 people. I need to take, let's say we take samples of 100 people. So we need to take lot of 100 people samples and then get mean of it. So what we do is we take sample of 100 people, get mean height of those men. Then we take another sample of 100 people, get mean height of them. We take such samples like 50 such samples or 60-70 such samples. We extract mean and standard deviation of all such samples. Okay. Now for each mean that we get, we will plot a graph of each mean. So central limit theorem says sample mean, when it is distributed, it will be approximately normally distributed. It actually depends on how large our samples are. Then we will get a perfect normal distribution graph. It is, the second line says, this holds true if our population is normal or skewed, provided the sample size is sufficiently large. Okay. So the sample mean for the random samples, we take the population, we can compute the mean of sample mean as mu itself, and the standard deviation of sample mean will be sigma by under root of n. So let's go with another example. We'll plot a graph and see how does it come. Now we'll see how can we actually plot such graph, how true it is that what a central limit theorem says. I have a dice, I can roll that dice for n number of times, it can be 1000 times, 10,000 times, and I'll be plotting the graph of what the outcome is. So the distribution of population, our population is roll of dice, and say I have rolled for 100 times. How does the distribution looks like? This is how it looks like. So when I actually roll the dice, I get dice 1 10 times, dice 2 20 times, dice 3 I mean the 3 number in the dice more than 40 times, and this is how 5 and 6 looks like. Now what I do, calculate mean and standard deviation of it. So mean will be somewhat here around 3.5, and when you calculate standard deviation, you will get around 1.2 something. So this is 3.5 and standard deviation will be 1.2 somewhere here and somewhere here 1.2. So this is how it looks like. Now we need to take sufficient amount of samples and get a mean of all those samples. Let's take a sample size of 5. Now I'll roll the dice 5 times and note all the outcome of it and find the mean of it. So this is what I do. When I take sample 1, roll the dice 5 times, this is what the outcome is. I get 1, 2, 2 again, 3 and 4. The mean of it is 2.4. I roll the dice again, I roll it for 5 times, I get 2, 3, 3, 2, 6. Mean is 3.2. I do it for a sufficient large amount of time, that is maybe 100 times I do this, and I get mean of all such samples. Now I want to plot this graph. Let's plot this graph. After plotting this graph, this is how it looks like. My first sample is mean with 2.4. So my 2.4 will be somewhere here. This is 2.4. Next is 3.2. 3.2 will be somewhere here. Next is 3.2 again. Again this 3.6 will be here. Now if you go here, if you go deep, there will be where mean is very large. So these are some points where mean is large. Most of the points will be around this mean, that is 3.5, and then there will be some which has very less mean, that is when you get all the numbers as 1 1 1. So their mean will be 1 only. So this is 1, this is around 1. There will be some samples where you get 6 6 6. So their mean will be 6. So this is 6. So this is how your plot will look like. It is more points you plot. See, if I took here, I took 100 points. Now if you go with 1000 points or maybe 5000 points, this graph will be more densely populated and more it will look for it will look like a normally distributed. My first one of the condition was, it doesn't matter our population is normal or skewed. Our population doesn't look normal, it is slightly skewed, that is true, but still the plot of mean of samples will be normally distributed. When I take sufficient large amount of numbers, say I plot this graph for 6000 samples or 7000 samples, it actually performs a perfect normal distribution with standard deviation as 1.2, that is of population, divided by square root of n. So this is what central limit theorem is. Again, let's repeat it by ourselves. Central limit theorem says, going to the previous slide, So going to the previous slide, central limit theorem says it is a statistical theory that if you have a population of mean mu, in this example we got population as mean as 3.5, standard deviation as 1.2, and takes sufficiently large amount of samples. So we took large samples as 5000, and then from the population, then distribution of sample means will be approximately normally distributed. That's what we saw. Even though population is not normal or it is skewed, this will always stay true if the sample size is sufficiently large. This is what central limit theorem means. That was it for today. I hope you like the content of my video. You can connect me on LinkedIn. The detail of my LinkedIn is in the description. Let's go with the drill. Like my video, share it and comment it. Thank you.